What's up, mama?
Hello.
Hey.
That's dope.
Alright, turn this music off, dude. Oh my god. It gets to me sometimes. What's up, dog? What's up, not your friend? Tuesday, dude. It's still raining in LA. It's been raining for like a fucking week. We never get rain here, ever, dude. No. Nuts. I don't know anybody
Yo,
else.
Gold, I'm actually cooking in math right now.
You're cooking in math? Dude, that's
That's
good.
dope.
Yeah, I keep getting 97. I have a 97 right now. I finished up with a 98 last quarter.
You know, you're one of my, like, my star examples of, like, progress, you know, in this,
I know.
in this
I
segment.
had like D's. I think I was a straight D student, like 68s. Now I'm straight A's.
I think I had one sec. Let me find the pitch deck. I gave like a pitch deck at like an education conference one time. One sec, where is it? It's right here.
I think I remember.
Yeah, you're on my slide here. Dude, is this you? Are
Yeah,
these
but my
your
grades
screen-
improved way more than that.
Yeah,
though.
your
They
grades are
went straight
even
A's.
better than this. Yeah. Now you got straight A's. I need to update this because this is from January to April. Yeah, of 2022. I need to be like.
Yeah,
and-
that was freshman year. That was all freshman year. That was in a year.
And now he's. Send me a screenshot of this. Do you have one of these screen? I'm sure you have. I'm sure I'll get the latest.
I have
one that you
another one.
send. Okay. Yeah. If you have the latest one with you, all A's.
Yeah, but this one I got a B in A push and AP Lang though. So
Do whatever. Those classes suck, anyways. What's up,
they're
Swab?
kind of hard.
They are hard. I know. Yeah, someone was telling me that. Well, yeah. Well, AP, dude. AP US History, bro. I had like the worst fucking AP teacher for that when I was in high school. He was so bad.
I sent you a look at the thing. It's in that's from last quarter.
Okay, let's see. Would you send it in good grades?
Yeah. I
Yeah.
peaked first quarter though. I almost got high honors first
I
quarter.
peaked. He says he peaked, dude. He says he peaked.
Bro, I was 2 points away from high honors.
Oh, 1 second. I gotta have the right. Why is this?
This is
not-
you now. Wow. Okay.
Show this folder. Oh my god, dude. What is it doing now? I need you to get this screen. Thank you. No, it's still not getting it. Okay, whatever. It's showing the wrong screen. Discord's weird sometimes. Okay, but yeah, here's your screenshot. Let me see it. Wait, where'd it go? Where's good grades, dude? There's good grades. Oh my god. Wait, you didn't post in good grades. Where'd you post it? Oh, there you go. Oh, you posted it in the chat. Pass
Yeah,
in the chat.
a bit.
Okay, much better. There we go. Yeah. Study hall, dude. What? You have a grade for study hall?
No, there's not a grade. They just put all the classes all there.
Nice. But the A in pre-calc. Yeah, I'm a fan of this. Yeah, this is great. We like this. This is
I went from a
excellent.
9. I did better in quarter 2. Hold up. Let me go. I'll post it in good grades. Sorry. Hold
Trey
up.
Johnson says, today I went from an A to a B minus. Nice. That's great. That's what I like to see. I like to see you guys doing better in school. It helps me
That was my
out
quarter
also
one.
because like when people ask me whether this actually works, you know, they're like, does actual education actually work? I'm like, yes.
Nice.
Because
Yes,
look,
sir.
you guys get better grades, right? So yeah, you know, donate. That's what I gotta tell these adults. I'm like, donate to my nonprofit so I can keep making kids, kids have better grades. Like what? Please? Yeah. Oh, I think we're up on donations. What are we at? Someone donated some more money. I can't see on the Twitch.
Damn.
What are we at? We
We went from 60 to like 100.
Oh, nice.
That's dope.
Nice. 117. That's dope, dude. Sweet. More
Look at
prizes
my
for you
thing,
guys.
Good grades.
Yes, I see it there. Nice. Yeah, pre-calc. A, yeah. B plus. Yeah, that's great.
I did better in quarter 1 than the second.
I like that. Whatever. We'll use one of these. One of these grades will look great. That's fine. Yeah. Enigma bot, unknown command, type commands. Wait, dude, how is this Enigma bot working? How is this bot like know to like watch my streams? I'm curious. I need to talk to Enigma. I'm curious how he codes all this stuff. Okay, super cool. All right. I know we got a lot of questions. We had so many questions yesterday. I apologize if I couldn't get to yours in time. Well, I got to everyone's who stuck around. I know some people eventually had to go because it was just, late at night and they were just like, "Yo, bro, like I got dinner or I got to go to sleep." But yeah, I will get to everyone's questions as long as they're here. If I don't get to your question before you fall asleep, this is why it's a good idea to post your homework question as early as you can in the queue. So there's a help screenshots channel. I'll let you post it whatever, like when the next day starts. Don't post it like a week in advance and then expect to be on the queue. Like if it's whatever day we're doing the stream, if your thing is in there on that day and you're first, your question gets first. But also you have to be present when I ask when I do your question. So if you're not here, then you get moved back to the end of the line, and then I got to go into the next student. Commands. Yeah, that's cool. I don't know how Enigma Bot is like watching my stream, but that's cool. I like it. Where was my achievement stream summary? Yeah, this was very cool. Yeah, so well, this is today's stream. Here we go. Yesterday's stream, we did 3 hours and 33 minutes.
That's dope.
That's a record. That's the longest I've ever streamed. I don't think I've ever streamed this. We had so many questions. 23 average viewers, that's great. 34 max, that's another record. I don't think we've ever peaked at 34. And then we got 173 unique people in on the stream, which is cool.
That's dope.
I was one stream.
Off one stream. Yeah, 173 people were unique. 247 people, so there's some duplicates there. And then we got 18 follows. I think what happened is we hit the discovery page of, was it for Twitch? So if you go to Twitch and you go to, these are all the channels I follow, but if you go, for instance, to the science and technology section, once you have a certain number, they'll put you on the front page. So like this guy, this paleontology guy is cool. I actually want to get him for an AMA, this paleontology guy. He talks about like, I don't know.
No, there you go.
Looks like he's talking about, this looks
yeah.
like
Nails in the Egyptian
evolution or something. But he's got a big following, 18K, sorry, in like 220 lives. So this is cool. But once we get large enough, we get put on this front page, which, see, here we are. We're down here now. So once this goes up to like 20 or 30, then we get put on the front page, and then people automatically discover this, and then this is why like everything becomes like huge and awesome. Yeah. How do you stream so long and have a job and a ton of hobbies? It's crazy. I don't sleep.
No.
That's basically. Amog will talk about how like I'm up at like 4 a.m. a lot of times. Yeah. Yeah, food chart thinking lit. Yeah. Yeah, and I mean, my job is very kind of like flexible, is what it is. I choose to work when I want to work, so I don't have like a 9 to 5 I go to. If I had a 9 to 5 to go to, I wouldn't be able to do this with you guys, which would be bad. And honestly, I may have to get a 9 to 5 at some point because the economy sucks. Rent's getting more expensive. Everything's getting more expensive, so I may have to get a job. I really don't want to get a job, because then I wouldn't be able to do this with you guys. So, let's see if we can get the nonprofit stuff to take off. That would be cool. All right.
Or
anyways.
you can gamble.
Or we could gamble. Yeah. Or what was it? Commit fraud or pyramid scheme, right? Fraud or pyramid
Fraud is
scheme.
crazy.
Commit fraud or pyramid scheme. Yeah. All right. Let's start off the stream. All right. Welcome everyone. Office hours. My name is Dr. Gold. This is Action Education, the stream that helps you out with math homework, science homework, life homework. I don't know. Anything y'all need help with. Someone submitted this. They wanted help with their handwriting. I was like, okay, that's cool.
Nice.
But I don't really know if this is like a legit question. What job do I have right now? Good question, Bob Ross's. I teach kids privately. So what I do for you guys here on the stream for free, I charge people in Los Angeles to do privately for their own kids. And I charge them a lot. I charge like $120 an hour because I have to. Otherwise, I wouldn't be able to like buy food or afford my rent. So y'all get it for free, which is why it's a great value. Yeah. He gambles on the side. I do not gamble. No, I don't gamble. I gamble with my life sometimes, but like not for money. Okay. Let's see what we got for questions. First up, not your friend. I have to go to school quickly. Okay, not your friend. Let's do yours real quick. Good job. Yeah, if you have to do something and you have to go quick, post your question first. Like, make sure you post at the beginning of the day. I will get to it as soon as I can. Okay, here we go. A lamina considering of a semicircle of radius A. Cool. What? Semicircle A of radius X. And a sector B with angle of 60 degrees, which is concentric. I love. Is this from Sri Lanka? Are you from Sri Lanka? Not your friend. That's pretty cool. I've always wanted to go to Sri Lanka. It sounds like a cool country. Oh, that's dope. Add that to the list of very foreign, cool, exotic places of the students that we teach. Okay. If the area of A and the area of B are equal, show that X satisfies this. Okay, and then X can take exactly one value. Cool. Awesome. All right. How do we find out the area of this semicircle A here? Not your friend. How do you do it? I need math and physics. Yeah. Do you have a degree in everything? Yeah, I have a PhD in physics. That's my degree. If people want to like know what, if you want to read my thesis, it's someone found me on LinkedIn the other day. They like sent me a message. I got to respond to them. But there you go. There's my thesis. And then if you want about here we go. About .drgold.life. That's like all my projects and stuff. You can see all my hobbies. Okay, 1/2 pi times r times r. Yeah, good. Yeah. So pi r squared, not your friend, that would be the whole circle, right? But we only need half of it, right? So we can just do a half. Cool. All right. So that ends up being 1/2 pi, and then the radius is x, so that's x squared. Cool.
Hey, Tatago.
What's up, Ethan? Okay, and that needs to equal, what is it? What does it need to equal? Oh, equal the area of B. How do I find the area of this sector here in B? This is actually a good one, Equity. Ethan was doing this earlier. Yeah.
Area of a sector.
Yeah, we need to figure out. Let's see if Equity knows it. How
Yeah,
do we figure out the area of
we-
a sector? 60 over 360 times pi times r squared. Yes, good, man. Yeah, hell yeah, dude. You're getting it. All right, yeah. 60 over 360, right? Because it's 60 degrees out of the full 360 times pi, and then r. Okay, this is where this gets weird, right? What's the radius of this sector? Right? This is kind of like a bigger. That's a square. This is like a bigger circle like this, right? How do I figure out what is this radius going to be? X plus 4. Yes, very good. Exactly. Good. So instead of r squared, this becomes x plus 4. Make sure you put the parentheses on this, and it's this squared. Okay? All right. Now we solve this. Pi's go away. Got pi on both sides. 60 over 360 is 1/6. And then this is x plus 4 squared. And then we got 1/2 x squared. Okay. This is a binomial expansion. Which, if we remember... And actually, what I'm going to do is... I don't like this. I don't like fractions. No. Fractions are ugly. So I'm just going to multiply both sides by 6. The reason I'm doing this, not your friend, is this 6 here will cancel this out, right? And then the 6 and the 1/2 here, what's that going to turn into? Just nice to have whole numbers. What's up, Pitbull? I have a Pitbull. Do you want to show a picture of your Pitbull on the Discord? I have a Pitbull. I assume you have one. Let's see. Not your friend's got it. 6 over 2. Yeah, what's 6 over 2? You know 6 over 2 is. 6 divided by 2 is... I know, it seems easy. But sometimes the most basic things are, like, crucial. Good. 3.
Nice.
Yes, good. Awesome. Okay. Good job, dude. So this is 3x squared is equal to x plus 4, all of this squared. This looks a lot nicer. I'm not dealing with any fractions or any ugly shit. All right. This is going to expand out into x squared plus 8x plus 16. Some of you guys may be tempted to say, oh, isn't this just x squared plus 4 squared?
No.
It's not. You don't just do that. This requires you to FOIL, and this is what they call, like, binomial expansion is what it is. Yeah. Good. Okay. All right. Now I got something that looks kind of nice. Let's just move everything over, because I like everything to be positive, at least with the leading term. So I get 2x squared minus 8x minus 16 is equal to 0. All right. This looks kind of cool. What's a common factor? I can pull out all of this. Not your friend. Two. Good, yeah. So I'm just going to divide everything by 2 is what I'm going to do, okay? Which 0 divided by 2 is just 0. Good thing we're not dividing by 0 at least. So this is x squared minus 4x minus 8 is equal to 0. And I think that's what they wanted to show, right? Yeah, x squared minus 4x minus 8. Cool, that's good. And then show with reasons that x can take exactly one value. Oh, okay. Fuck, why is that? This doesn't factor nicely, which is ugly, but okay, fine. So quadratic formula. This is a quadratic. So anytime you have a quadratic, you got to use the quadratic formula. So this is, so a is equal to 1, B is equal to -4, C is equal to -8. Life, yeah, life if it was, dude, would be so much simpler. Hello, hope I'm allowed to be here. Not a student, but enjoy learning and terrible at math, so I thought I'd have a look. Find you for your science. Oh, yeah, for sure, Red Finky. Welcome, dude.
That's dope.
Yeah, this is for all ages. Yeah, don't worry. I don't have like an age cap or an age minimum. I mean, I think Twitch technically says you have to be like 11 or 13, but whatever. I don't care. Yeah. If you just want to like, and if you have any questions yourself, please, we have a Discord where you can submit like whatever question you have. I don't know if you're like self-learning or whatnot, or you just want to like refresh your math knowledge. I go over almost everything here. And yeah, let's get you better at math, you know. Everyone should be good at math. People aren't terrible at math. I say they just haven't practiced enough yet, or they haven't had the right teacher. Most people have terrible fucking teachers in math. Okay, x, right? Once we have something that's here, something squared, something to the first power, and then something to the 0 power. This is the quadratic formula where you do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then I just substitute these things into here, right? So that's going to give me positive 4 plus or minus the square root of negative 4 squared, which is 16, minus 4 times 1 times minus 8, and then all over 2 times 1. Let's see what we get here. We get 4 plus or minus... Oh, I don't like this. Oh, actually, I do like this. This is 6. So the minus 8 and the minus 4 will become positive.
Nice.
If you need that, yeah. And then, oh, thanks Medkit Man for following. Medkit, you've been here for a while, dog. You're just following now. So this is 32. 16 plus 32 is 48, and then this is 2. So I get 4 plus or minus. Okay, and then let's reduce the square root of 48. Not your friend. This is a good refresher for everybody else. You know how to reduce. This is called reducing radicals. So if I have a square root of a big number, I can write it as a smaller square root. About that 10. Yeah, just refreshing, yeah. Yeah, about 10. Yeah. Bum, 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 bum. He's typing. He's a typing. You don't have to tell me what the answer is. Just tell me, like, what would the step be? Like, what would I do next? Yeah, I was never good at reducing radicals. Okay, well, let's get good at it. All right. The trick to reducing radicals is you just got to break this up into what are technically called prime factors. I know that's like a weird word. It just means you have to break it into numbers that can't be broken down anymore. Like, you can't get more multiples out of them. So, for instance, with this one, so you can be clever. If you want to be clever, I'll show you 2 ways to do it. Well, let me show you the basic way that'll always work. If you have an even number or something like this, just pull a 2 out of it. And then think, okay, 2 times what gets me 48? Yeah, do you guys call this surds? I've heard that before. That's a weird-ass word. we don't call it surds in the U.S. Yeah. But this, yeah, they teach us surd. Oh, I see. I think the RD is reducing or radical, I don't know, whatever it is. Something. Yeah, okay. But basically, you take this 48, you say, okay, cool, what can I factor it out to? And I say it's 2 times 24. Awesome, cool. I can't break the 2 down anymore because that would only break down into a 1 and a 2. And that's nothing new. So we leave that as it is, okay? So then we're going to break down the 24 into 2 and a 12. And then we can break down the 12 into a 2 and a 6. And then we break down the 6 and a 2 into a 3, okay? At this point, you're done. Because 3 can't break down into anything else, right? 1 and 3 is if the only thing it can break down to is 1 times itself, you're done. You can't go any further. All right. And then the last thing to do is to pick out the pairs, okay? And anytime you have a pair, that comes out as a single number over here, right? So this is going to come out as a single number over here. And these are always multiplied by itself. And then whatever is left goes back inside the house, being multiplied, okay? So in this case, this would become 2 times 2 times the square root of 3, which is the same thing as 4 square root of 3. Yeah, is it a lot easier? I don't know which way they teach you it. Yeah, this is the way I like to do it. The other way, if you wanted to be clever, here, just to like save yourself some time, if you know you're going to be able to pick out a number twice, here, exactly, the perfect squares, you can do it this way as well. You can kind of cheat and go ahead. So, for instance, I know that 48 is going to have 4 a couple times in it. So I could do 4 and then 12 and then 4 and then 3. And then what I notice is, okay, cool, I got the pair of 4s, right? That comes out as a single 4. The 3's left, all right? That's the same thing. That's still 4 square root of 3. But notice how I had to do less steps. This you had to keep going down a couple. So again, if all else fails, like just do this. It'll always work. But if you want to save yourself some time and you want to be clever, you can stop if you find that there are a pair of numbers you can pull out. It's kind of the trick. Yeah. Yeah, cool. But yeah, this is an easy way. It works. The reason why it works, you're good. Yeah. The reason why it works, guys, is essentially what you're doing is you're saying 48 is equal to 2 times 2 times 2 times 2 times 3. Like all of these things multiplied together equal 48. If you don't believe me, you can just do it, right? 2 times 2 is 4, 8, 16. 16 times 3 is 48. And then what you're doing is you're grouping these as 2 squared times 2 squared times 3, okay? Which is equal to 48. So then the square root of 48 is the square root of all these things, which is the same thing as the square root of 2 squared times the square root of 2 squared times the square root of 3. And the square root of something squared just gets rid of it. So this is just 2. Like the square root and the square root, they cancel each other out, right? These things like kill each other. So this kills out this. So then it's 2 times the square root of 3. It's the same thing, 4 square root of 3. That's why it works. So maybe your teacher with SIRS makes you do this, but I don't know. This is it's funny. I had to do this for a job interview like the other day or something. They asked me about conceptual versus procedural versus like application when teaching a concept, and I think what happens too often in your classes is your teacher jumps right to conceptual. Like they jump right to this. They're like, oh, well, you should understand the concept of this, but you don't get it. And so then you like throw your hands up and you're like, I don't know what's going on. And then you stop learning. Whereas, if we show you the procedural trick, this is like the mechanical way just to fucking do it. And you're like, okay, cool, I can get the right answer. Then I think you start to appreciate like conceptually math like this. Yeah. Oh, yeah. You like applications better, Pub? I agree. Applications are better. Problem is, at the end of the day, you still got to do you still got to take a test. You still got to do your homework. So, and I'm not sure. I mean, maybe there's an application here I could come up with, but it's nothing like fun yet. The things that have fun applications are like physics and stuff. Some of this basic math stuff is just basic toolbox stuff you need to learn. And if you don't know it, you can't do the cooler stuff later. It's like learning to ride a bike. Like learning to ride a bike is probably pretty fucking boring. But once you know how to ride a bike, then you can ride a dirt bike, or then you can ride a motorcycle, and then you can do like more fun stuff. So that's kind of what I see is like you got to learn the core skill of like, can I balance on a bicycle, and then you can start doing jumps and stuff, on a dirt bike.
That's dope.
Calculus, lots of applications, yes, but to do calculus, I got to teach you this. Anyways, so this is 4 plus or minus. This thing became 4 root 3 all over 2. And now the nice thing is all of these things have factors of 2 in them. So I can cross out the 2 on the bottom. So this is going to become 2 plus or minus 2 rad 3. So the 4 over 2 and this over 2. A common mistake that will happen is if, say for instance, this thing is 1, people will think they can just cross this out and make this 2. You can't do that. If you want to reduce this, if you want to get rid of this thing and simplify it, it has to go into both things. If this is just a 1, that doesn't work. You can't do it. So, anyways, this is a 4. So there you go. 2 plus or minus 2 rad 3, which I don't know. What is rad 3, dog? Rad 3 is 1.73. Okay, cool. They give you that at least. It's too funny. You said your teacher doesn't let you use calculators like at all. Like what? Can you not like afford them or like what? Like. I feel like you should be able to use a calculator for this. It's prohibited. Oh, interesting. Oh, okay. That's cool. I mean, I agree. You should learn how to do things by hand. because relying on a calculator is like having a crutch. But at some point, you know, I mean, this sucks. You can't do this in your head. So anyways, this is 2 plus or minus 2 times 1.73, which is 2 plus or minus 3.46. And this is why we say there's only one unique solution for x, because my solution is either 2 plus 3.46, which is going to be 5.46, or it's 2 minus 3.46, which is negative 1.46. Now, negative 1.46, like, intuitively doesn't make sense as an answer. Like, I can't have a negative radius. I mean, not in the real world, at least. So that's why there's only one answer for x, 5.46. Yeah. Okay, cool. So this is going to be r is equal to 5.46, and you're done. Nice.
That's dope.
Nice. Good job, Not Your Friend. Good question. I enjoyed that one. And here, yeah, you're welcome, dude. Yeah, and I hope that made a little bit more sense for, you know, people watching with, again, every question will have other parts of math involved with it. So even if you may be like, oh, I already know how to do the area of a circle. Cool. You may not remember how to do radicals. So that's why, you know, watching these types of questions will help you out with all your other stuff. But cool. All right, there's your question. Let me pull it in. Now I got to rush to school. All right, good luck, dude. Good luck. My university doesn't allow calculators in exams. At least the math department does. Yeah, most colleges don't, actually. Because most stuff you do in a college class is all symbolic. So it's nothing to do with numbers. They don't care about numbers. They care about, can you do this with variables? So that makes sense. All right. Equity. Is Equity here? Let me see if Equity's here. If Equity's here, I'll do his. Sir Equity. Equity says he's busy. Math becomes language class. It does, man, dude. It really does. Yo, what's up, Equity? Okay, cool. Which one you want help with? Pick a number. 1 through 8. Which number? These are all the circle theorems. Like, like, I'm cool with triangles, man, but like the circle theorems, I don't know, dude. There's just so many of these things. What is it? I gotta look up, like, was it circle theorems? It's all these, yeah. These things, they hurt my brain, dude. Okay, here we go. I like these. Yes. Okay, cool. There we go. Got it. Yeah, these are useful. Okay, let's maybe do, I mean, number 1 is easy. Like, this is dumb easy. This has to do with this one. Let me think what's a fun one, though. Oh, man. What do I want to do with this? Let's try 8. 8 looks like it's like nightmare hard, honestly, this one right here. Okay. So, yeah, do you want to try to do 8? I don't know. This looks kind of fun. I say this as like I'm about to get screwed. Okay. Which rule is this? All right. Oh, okay. I don't think this is too bad. All right. I think to figure out n, we first need to probably know what like this angle is. I think that might help us. I could be wrong, but I'm pretty sure. And I think for this rule, we're going to use this, which says that if you have an angle, right, that is formed from the center and it like touches 2 endpoints. So let's say this is point A and point B, that the angle formed by those endpoints connecting anywhere else on the circle is going to be half of that, okay? So here I have this and this, okay? And here, we'll use the same colors that they use. So they use like the blue. Oh, I need a thicker blue here. They use like the blue here and the blue here, right? So this is the angle formed from the center. And then we know this angle, the one in the green, has to be half of that, okay? Just a good thing to know, at least, okay? So I know that this is going to have to be half of 142. So this is going to have to be 71. Okay. Does that help me? Maybe Maybe not. Let's see. When I was at school many years ago, I was told we weren't allowed to use calculators because it's not like we'd have one in our pocket whenever we needed it. Then smartphones were invented. Yes. But, you know, your smartphone can die, you know. This is why I wear, like, a manual watch because I got sick of those smartwatches just dying, like, every day. I don't want to charge something every day. It's just bad. Yeah, so, I mean, it's still helpful. Also, like, being able to do mental math in your head fast trains you to be able to do other tasks fast. I say a lot of like education, especially like when you kids in high school are probably like, why the fuck am I learning this? This doesn't make any, like, I'm not going to use this ever, blah, 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 blah. You're true. You may never use it ever again, but what you're learning is how to think. You're learning about like a thought process of like, how do I take something I don't know and solve it? Because everything in life is taking something you don't know and then solving it. And if you can do it with math, you can probably do it with other things. So that's why you're learning it. And if your natural reaction to these things is to give up and like not solve it, it's not gonna help you out later because there are a lot of problems that happen in life, and you have to be able to step up and solve them. You can't just give up. Absolutely helps. Yeah, great. Okay, but how do I figure out this one, dude? What the hell? Oh my god, dude. What? Okay. Ooh. I think I know. I think this is really whack, actually, how we do this one. Okay. Watch this equity. Okay, equity. Okay. If this is 142, what is this going to be? Yes, yeah, good. Yeah, Jamarcus already got it. You got it, Jamarcus. That's exactly what I was thinking. Yeah, but if this is 142 equity, what is this? What's the rest of it? 360 minus 142.
Nice.
Exactly. Okay, quick math. Dude, what is that? That's 218? Is this 218? Yeah, there you go. Yeah, 360. Okay, cool. Awesome. And then, yeah, Jamarcus is absolutely correct with the last part here. So this shape right here, this whack-ass thing, is technically called a quadrilateral because it has 4 sides, okay? And just like a triangle, which has 3 sides and is always 180, a quadrilateral with 4 sides is going to be adding up to 360. The formula for that, I believe, is n minus 1 times 90, where n is equal to the... Wait, that's not right. One sec. 3 sides. Wait, is that right? Number of sides? One sec. I forget what this one is. Interior angle. Oh, it's 180 n minus 2 over n. Okay, all right. Oh, wait, no. Well, that's a regular polygon. What is it? Okay, it's n minus 2 times 180. Sorry, it's not n minus 1 times 90. Yeah, that's what it was. Yeah. So it's n minus 2 times 180 degrees. This holds for any polygon. So whatever number of sides it has, subtract 2 and multiply by 180, and that's the sum of the interior angles. That's sum of interior. So in this case, we have 4. So 4 minus 2 is 2. 2 times 180 is 360. And so I know all of these must add up to 360. So now I have 50 plus 71 plus 218 plus n is equal to 360. All right. Can I do this in my head? This is 268 plus 71, which is 339, I believe. Someone check my math on that. And that's going to be n is equal to 21. Yeah, 21 degrees. There you go, equity.
That's dope.
Yeah, that's a cool one. Adds up to 360. Good. Yeah, here, I'll get this one for you. Are these questions you have on like your homework, equity? I'm just curious. Like, or is this just you're just learning for fun? Like, I don't care either way. Because I learn things too. I like learning things. Learning things are cool. Big fan of learning things. Oh, it's review. Okay, cool. Good. Well, yeah, I hope that this helps you. And then, yeah, this thing is probably the main thing I would study would be this. I think you need to know that. I try to always find, I don't want to reinvent the wheel, so I always try to find on Google Images like a good like review sheet thing diagram that someone's already made, and I have a pretty good sense for what has all the information. So that one's pretty good for the circle theorems. I feel like that and the periodic table I should get like tattooed on my like arm at some point. My mom would like kill me, but I don't know. I'm always like looking up like where is this? Ooh, I like this. All right, Taco Cat, you ready? We're gonna do geometric sequences. This is cool. Taco. And then QV and then Swaz, you're up after that. Where's Sir Monkey? Maybe he could be playing Fortnite. I'll give him 20 seconds. Imagine walking to a chem class and you pass by looking at your periodic table tattoo. He's eating a big long banana. Oh, he is here. Okay, cool. What's up? Nice. What's up, Taco? Hi, I'm here. Yeah, cool. Do you want to try here? Let's try to do. Well, this would be pretty easy. So, okay, instead of finding the fourth term, instead of finding the next term, I want you to find the. Actually, you already know how to do this. I want to do an even funner one with you. Yeah, no, I see you, Monkey. You're good. One sec. Let me design a question for you. One sec. I gotta come up with some good numbers for you. Yeah, here we go. No, but not that one. 4 times 3. Yeah. Okay. Here. This is a cool one. All right. Let's say I know a series is geometric. Okay. And the 5th term is 972. And the 7th term is 8,748. What is the 3rd term? It's a cool little puzzle. Dr. Gold, when you have a degree in plasma physics, why don't you want to get a job? It's a very good question, actually. It's kind of a long answer to that. I just found out that I was better at teaching. I'm better at doing this. I'm like a lot of people in plasma physics don't really have the ability to communicate ideas or like distill concepts down. And as much as I did love plasma physics, I originally went in to do plasma fusion, but I saw that the amount of delays and headaches and whatever with doing research in there, I was like, man, this is not for me. So I got the degree. It was cool. I learned a lot. Doing a PhD teaches you a ton about problem solving, perseverance, self-motivation. Like no one tells you what to do in a PhD. You have to figure it out. So it's a very valuable thing to have. But I didn't want to continue doing it because I hated my life. And I have more fulfillment, enjoyment doing this, teaching you guys. So that's why I switched. Plenty of people do that. I mean, most people in my field that got plasma physics degrees do not do plasma physics. They're like quants for finance companies, or they do hedge funds, or they're software programmers, or they're in AI. So, just because you get a degree in something doesn't mean you have to do it for a job, but it definitely helps to have the skills for other things. Yeah. But okay, yeah. So, okay, this is cool. So we say we have a geometric series where the 5th term is this and the 7th term is this, and we want to figure out the 3rd term. This is kind of weird, right? What jobs could I get with my degree? Probably whatever, honestly. What? It's actually kind of a double-edged sword, Bob Ross's, because the problem is you become almost like too qualified for things. So, for instance, because I have a PhD, a lot of jobs think they need to pay me a lot of money, but they don't want to. So they don't. And so that's why it's kind of hard to get a job sometimes if you have too much education. Certain jobs. But it definitely helps for higher level things. So a lot of my buddies, again, ended up doing finance, or they ended up doing software engineering, or I'm trying to think what the other ones do. Some of them are scientists. Like, they work in physics labs. You can definitely do that. You can work in a physics lab. Or you can teach. Yeah, lots of things. My sub is about to run out soon. Okay, well, let's make sure you get it then. Okay. So let's remember, for a geometric series, a sub n is equal to a sub 1 times r to the n minus 1. Right? Do you remember this, Monkey, for a geometric series? It was kind of similar to the arithmetic one, but this is for things that are like multiplying over and over again. So if I know the 5th term is this, okay, that's like saying this. So I know a sub 5 is equal to the 1st term, which I don't know. I don't know what the 1st term is, times the common ratio, which I also don't know. I don't know the common ratio. But then n minus 1. What would n minus 1 be if n here is 5? What is this going to be? Chat is slow for me? Oh, then chat in the Discord. It's faster in the Discord. Bob Ross says, as a plasma physicist, what would you do? Oh, you would study plasmas. So that could be anything from fusion research, or you could be doing, for instance, Intel. Like, a lot of microprocessors use plasma processing in order to make their microchips. So that's another big one. And then a lot of space stuff. All of space is plasma. So you do a lot of study with space. Yeah. Okay, what's up, Taco? Yeah. So, right, this is 5 minus 1, so this is to the 4th. Okay, cool. Good. All right, and then how would I write the 7th term thing, right? A sub 7 is equal to A1 r to the what? That's taking like this information. Do you think theoretical physics would be a career that makes enough money to live a decent life? Ooh. Tricky question. It should. Okay, so if we talk about like going into grad school, there's already a split once you get into whether you do theoretical physics or experimental physics. Experimental physics has a lot more money in it because, again, there is practical applications to experimental physics. Theoretical physics tends to be harder to get money. So there's already kind of a struggle there for grad students to get paid. But if you love to do theoretical physics, you should. And if you're good enough at something, you will get paid for it, is what I say. So don't ever just go into something just for the money. If I were to do that, I'd be in stocks. But like, I'd hate my life. Don't do that. Yeah. Good. 7 minus 1. This is the 6. Good. I see it on my screen. It taking time for it to come up. Oh, that's weird. Yeah, it's okay. So the Twitch is going to have a delay. Discord should be instantaneous. I'm bad at understanding things on my own. It's okay. You'll get better. You're in 8th grade, dude. Like, I didn't know shit in 8th grade. Okay. This is 972. This is 8,748, right? Remember the 5th term, Taco, was equal to this. And the 7th term was equal to this. Right? So there's actually a kind of cool thing you can do here. So when you have two of the terms, this is technically what's called a system of equations. Because you have two equations here. I have an equation here and an equation here. And I have two things I don't know. I don't know A1 and I don't know R. Okay? This is a good trick. Like, beyond knowing geometric series and whatnot, this is a very good trick for being able to solve these types of things. If I see, for instance, the same variable being multiplied on both equations, what you're going to want to do is you're going to want to divide one equation by the other, all right? So let me call this equation 2. Let me call this equation 1, right? Remember, the 5th term was equal to this. The 7th term was equal to this. So this is like my whole thing, and this is my whole thing. Watch what happens if I do 2 divided by 1. This is similar to the elimination method that you do in systems of equations, where you do like one of them minus the other ones, but we're going to divide them. So watch what happens when I do that. So that means I'm going to take this, and we're going to divide that whole thing by this. This is a very cool algebra technique that, I don't know, it's super useful. I don't know how much it's taught in class, but I'm showing it to you, so secret. Okay. Now what you can do like just basic algebra here, all right? Where I can divide this by this, and then I can divide this by this, okay? So, what is this going to be, Taco? What happens if I divide this by this? Is anything going to, like, cancel out? Am I going to get some... There are going to be some exponent rules here, too. What's up, Ethan? Ethan, do you know how to simplify these two things?
Simplify. Well, I remember the laws of indices rule. Can I do the R one?
Yeah, you can do the R1. Do the R1. That's great. Yeah, what's the law of indices, Ethan? Yes. Yeah. Can you not hear me? Well, I hope everyone else in the chat can hear me. I think so. Bum.
That's go. I'm sorry, my audio is bugging out right now.
It's okay. Can you hear me? Yeah.
Yeah, I can now. I can.
Good. Yeah.
But
Taco
yes.
Cat.
So
Taco
what we
has what I
see,
do. Yeah. So how do I reduce these? How do I reduce these?
you got in the laws of indices rule, if you're dividing like an exponent with one of those square things or the little exponents, then you gotta subtract them. So it's like 6 minus 4, which will be
Good.
I2.
Good. Exactly. Yes. Yeah. And Taco Cat, you had the right idea. Just careful how you write it. So when I'm doing this, this is r to the 6 over r to the 4th, right? And r to the 6 over r to the 4th is r to the 6 minus 4, which is equal to r squared. Good.
We're not subtracting the r itself. We're just subtracting the exponents.
Yes, we're not subtracting the r. Very good. Very good. Yeah. I always say, like, be careful. Because what we're doing is we're subtracting this. We're subtracting these exponents, the indices. Good. And then what happens with the a1 over a1? What happens when I have a1 over a1, right? I have a1 over a1. What happens to that?
Don't they just cancel out or something?
Mm-hmm. Yeah, these just go away. Goodbye. Cool. So this goes away, and this now becomes r squared. Yeah, they cancel out. Very good, Taco. And then do you see how this is now just going to become a number? Because this is just going to be, okay, cool, 8,748 divided by 972. Which, I probably need a calculator for this one. Oh, let's plug. I mean, let's not struggle today. It's Tuesday. 8,748 divided by 972, okay? And that's going to give us 9. Okay? So this gives me r squared is equal to 9, all right? If that's true, guys, what does that mean r is equal to?
X squared is equal to 9. Then that should mean that it's 3 times 3.
Yeah, 3 times 3. Yeah, very good, Monkey. Yeah, good. Good. So this is just gonna be 3. Yeah. What is this doing? What's up?
So I actually posted a complete different question. It was based on what equity had yesterday. Remember the one that I was kind of struggling with?
Yeah. Okay. We'll go over it.
Yeah, it's kind of something similar, or it's the exact same thing, and you just didn't use the cosine rule.
Yeah, you could probably use the left side rule. Okay. R is equal to 3.
Yeah.
Okay, so we know R is equal to 3. But now, I still need to figure out what A1 is, right? Because if I know what A1 and R is, then I can figure out what the third term is, right? Because Sorry, let me move this over. Okay, because the third term is A sub 3, which is equal to A1 R to the 3 minus 1. Right? So that's going to be R squared. which, yeah, we already know R, and we even know R squared. R squared is just 9. But I still don't know A1, right? So I have to figure out what A1 is. The way to do that, guys, is to use one of these formulas that we already know, right? So, for instance, I already know that A1 R to the 4th is equal to 972. And R in this case, remember, was 3. Okay? Does that make sense so far? I know, I kind of jumped a couple steps there. Yeah, okay. 3 to the 4th is, what is that, 243? Is that 243? I think it's 243. 3 to the 4th is, no, 81. I'm done. Yeah, sorry, that was 3 to the 5th. Yes. So this is A1 times 81 is equal to 972. He says, I believe A1 is 12, or let's see. So 972 divided by 81 is going to be 12. Good. Yeah, very good. So I get A1 is equal to 12 in this case, right? Okay, very good. Yippee. Yeah, good job, guys. Okay, so now, if A1 is equal to 12 and R is equal to 3, right? Now I can plug both of these in to here, okay? And that's going to get me 12 times 3 squared, which is 9. And so the 9 times 12, which is equal to 108, okay? And you're done. What's up, JJ? It's crack-a-lackin', dude. Nice, good job, Taco. Taco, did you decide what prize you want for the what was it, for the drawing yesterday? I was gonna say you can combine things. So $30, I think I could get you a $20 V-Bucks card and a $10 V-Bucks card, or you could wait for you to win another $10 thing, because then I think I can get you a 40 or something, right? Isn't there another bonus at $40 or something?
I think so. Yeah, I think the next one costs like $49.99.
No, I think it's like 37.
I can't remember.
But yeah, PUBG. Yeah, radical X is X to the 1/2. Exactly correct, dude. Yes. Mention Taco Cat. Okay. All right. Let's do QQVNT. QQVNT. He says, I miss school. Uh-oh. Did you get sick? I have a couple people who tell me they have COVID or something today. Couldn't teach them.
So I actually posted my math question related to
Okay, did you post it in the screenshots?
Yeah, wait, I already said that. Sorry, I already said that, yes, but
That's okay.
I did do that.
Okay, cool. I see it. And then I see Jamarcus's. Jamarcus asking about energy frequency. Yeah, that's cool. Yeah, all right, cool. All right, and then, well, we got Swaz right after this. Engineering essentials. This is going to be fun. All right, what's up, QQ? Okay. Which of these graph is correct for the cooling curve for water? Ooh, I like this. This is cool. Yeah, this has to do with, what's it called? Latent heat or something? Yeah, this is what I want. Yeah, but better picture. I mean, this is kind of cool, but nah, fuck this, dude. Okay, I kind of like this. Yeah, okay. This is kind of an okay image. All right. Yeah, this has to do with heat of fusion and heat of vaporization. Okay, so right here, guys, is a graph of the temperature of something versus how much energy I'm putting into it. Okay. So if I have a solid block of ice, right, and let's say it's like very, very cold, okay, and I start adding energy to it, right? I start adding heat. I start putting it on like an oven or a burner or something, right? That is going to raise the temperature of the ice until the ice hits a certain temperature. In this case, it's 0 degrees Celsius, right? And this is when the ice will stop coming up in temperature, but will start melting, okay? And as I put more and more energy into it right here, right, the temperature does not change. And chemically, what's happening here is this like kind of this plateau here is the energy it takes in order to break the bonds of a crystal lattice of ice. So ice is well, let's just get like a let's see, H2O in different forms. Yeah, but okay, where is it? Yeah, here we go. This is very cool. Very cool. I like this. This is a great graph. Or whatever. This is actually even cooler. We'll take this one. This is a good chemistry concept here. I'm learning about this. Yeah, this is very cool. Actually, and there's a lot of very cool properties of this. Actually, is why life exists on Earth. It's actually quite cool. So, yeah, when water molecules are in the form of ice as a solid, they're bound together in what's called like a lattice. So it looks like a very nice organized piece of whatever. And the temperature associated with this ice is the temperature at which these things vibrate, okay? So as you add more energy to the ice, these things will vibrate more. And the more they vibrate, the higher the temperature is, okay? Eventually, you add so much energy that these things are vibrating enough that these bonds here, these are called intermolecular forces. This is another thing we did last lesson. I forget, someone asked about intermolecular forces, but yeah, these are called hydrogen bonds. But these will start to break, okay? Oh, it was you? Cool. Well, this is where it comes into play, right? So, once you've put enough energy into here, enough temperature, in order to reach the melting temperature, then what happens is no longer is the temperature increasing, but now all the energy is going into breaking the hydrogen bonds. And so the temperature stays the same while the bonds break and it starts to melt. This is what happens when you have like ice and water, like icy water. You probably notice this, you know, like, I don't know, if you get ice in like a soda cup or something. You know how there's like a little bit of ice and a little bit of water? That's this state. It's an in-between, okay? Eventually, you melt all the ice, okay? And all the bonds are broken. And then what you get is water molecules as a liquid, okay? And these things still also have intermolecular forces between them, but they're not as strong, I guess. You know, it's not in a lattice form. So they're more kind of like, they're flowy. You know, they kind of move around a little bit. And you can keep adding energy to that, and the temperature of the water will keep going up. But you know, right, that once you add enough energy into this water and the water reaches a certain temperature, which does anybody know what this temperature is when it starts to evaporate? It's a good one. Do you know, QQ? Nope. Okay, that's okay. This is 100 degrees Celsius, okay? This is also why Celsius was invented, because 0 is melting and 100 is boiling, is what it is. Yeah, it's really nice. In Fahrenheit, I think this is 32 degrees Fahrenheit, and I think this is 212 degrees Fahrenheit is what it is. Yeah, this is why Fahrenheit's ugly. But we use it in the US of A. So yeah, so once you get to 100 degrees, all right, now the energy, again, goes less into vibrating these things and more into breaking the attraction between them, such that they eventually get liberated from each other and they turn into a gas. And now they're super free, okay? So that's when you start getting, this is kind of like the nice little graph I show. So if I have like water molecules here, eventually they start going so fast that some of them will exit the water and turn into gas form, into steam, okay? The supreme continent, Americated, yeah. Yeah, Rat Finky, it's 100, yeah, exactly. So yeah, so again, and there's a lot of energy that you have to put in order for the water to finally all turn into steam. And then once it's steam, okay, then you can keep adding heat to this thing, and it will keep getting higher and higher temperature. You can keep adding more energy. This is why, for instance, okay, so water, right, when you boil it, when water is boiling, it will always only be 100 degrees, okay? This is a very cool thing. I can go into like heat of vaporization. This is why, for instance, it takes longer to cook foods at higher altitudes. There's a whole thing with this, which is pretty cool. But in general, this is why boiling water is always 100 degrees. and it won't get any hotter. Boiling water can't get hotter than 100. Kind of in the same way, I mean, ice can't really get lower than 0 unless you add salt to it or start doing some other stuff. But steam can. So you need to always be careful. If you're boiling water and like all the steam is like being built up like in a pan, like, you know, in a lid or something, and you pull the lid off, the steam can be hotter than 100 degrees, and that can really burn you. And that's what superheated steam is called. Oh, good to see you, Right Thinking. I'm glad you got to learn some stuff. Yeah, take care, man.
That's dope.
Feel free. Our schedule is we teach 3 times a week. There's our schedule. So we'll be tutoring tomorrow as well. So my fart can be solid, liquid, and gas if the temperature is right. Yes, I guess so. But I don't know what the melting temperature of fart is. I mean, that's probably a lot of stuff, you know. Yeah. Well, I guess that's like fart, diarrhea, and like just taking a massive solid shit. Like, whatever. Yes. Technically, those things are yes. Okay. All right. So this is what the graph looks like. So when we're looking at the cooling curve for water, right? Remember where the flat points happen, right? I need one of the flat points to happen at 100, okay? So this is the only one that has a flat point happening at 100, and the other flat point has to happen at 0. There's a specific point of sulfur content in farts where they begin to smell sweet. Ooh, I didn't know that. It's an interesting fact. Yeah. But yeah, so do you see how this one has a flat at 100 and a flat at 0? 0 and 100? So that's why this is going to be this one. It has to do with the melting or freezing point of water and the boiling or vapor or condensation point of water. Yeah. Okay. Use the following table heating curves to master graph the substances. Fill in the IMF. I mean, this is, again, we did this last time. You're just looking at stuff. It's kind of cool, though. Because you can see things with higher temperatures usually have higher boiling points. Actually, I don't know. Well, this doesn't really work, right? Because glycerin is dipole, but is like a much higher boiling point than this. But this comes from the table. That's not too bad. I assume you know how to do that. Oh, okay. But this is cool. This is cool. Let's try to do this. All right. So looking at these graphs, right? What is this top bar? What point is that? What did we say that top bar was? And then what did we say this bottom bar was? Remember when we had it here, right? This and this. This is like a heating curve. This is a cooling curve. It's just the opposite. One's like adding energy to get hotter. One's like losing energy to get colder. Solid and evaporation. Yeah, exactly. Good. Yeah. So solid is what's called the freezing point. This is freezing. And the evaporation, this is called boiling. Okay. So in this case, you're looking for something that has a freezing point, around 0 and a boiling point around 270. So I look at this, I'm like, okay, cool. Where's my freezing point around 0? It's probably around here, right? This is like the 20. And then where is it around 270? Well, here's 290, right? So this one is probably glycerin. Do you see that, QV? Okay. Then what about this one? What's the freezing point? What's the boiling point? What material would that be? What do you think? Which one do you think that one would be? Stearic acid, he says. Okay, let's see. I kind of agree. Yeah, right? 70 and then 360. Yeah, that looks cool.
Nice.
I agree. And then last one. Which one's this? Iodine. Yes, good job.
That's dope.
Good job, guys. Yeah, good job, PUBG. Nice. Sweet. Does that make more sense to you? Yeah, sweet. Yeah, okay. I'll download this for you so you can see it.
Yeah, that's
Nice. What's up, dude?
So, I want to tell you a good thing
What
that
do you want?
happened
What's
to
the
me.
good thing? What do you want to tell me? What's the good thing that happened to you today?
Do you know what's the debate? First of all,
I do know what a debate is. I deal a lot with debates. Swaz, you're up next.
okay, okay, and you know, I really don't know what happened to me, but it was really crazy.
What happened? What happened, dude?
Basically, when it was my turn to present, um, I stood up, I read what I had on my index cards, and when I was speaking, I was clearly projecting my voice, and it was as loud as a tiger.
Nice.
That's dope.
Yeah, public speaking skills, bro. Very important. Important things to have.
And when I was finished, the teacher said I did a very good job.
Nice, dude. We love it, dude. What were you debating about, by the way, bro?
Wait, what?
What were you debating about?
Oh, why sex education cannot be taught in schools?
Why sex education cannot be taught in schools?
Should not, should not.
Oh,
Should
should
be taught in
not.
schools.
That's a fucking loaded question.
Yeah,
I would be
I
curious
know,
to
I
hear
know.
what your debate was about that. I would be very curious, but not right now because I have to do this question. But that I have my own opinions.
You know,
on that.
people. One of my own students said a really weird word.
Okay, what do you say? Now I'm curious.
Okay, I'll DM you this.
All right,
Hold on.
DM
I don't
me the
want
word. All right.
anyone. See.
Okay, you don't have to say it publicly. It's okay.
Yeah, see, I said it. I put it in the DM.
Okay, cool. We didn't. I grew up in Texas, so we didn't really have sex education in school. Oh yeah, that word. Okay, yeah, that makes sense. But yeah, and I think it really kind of screwed some people up. But I have my opinions about it. I think there's a certain age that should happen at, and I don't think it should be younger than a certain thing. So, like anything, I think there's always an in between things being but there's always a truth somewhere in between, and people tend to pick the extremes for things, and I don't like that. All right, bye, monkey. Good to see you, dude. Yo, I go to dinner. Do I still get a bond coin? Yes. Yeah, it's okay, Jamarcus. I'll give it to you. You're fine. Okay, what's up, Ethan?
Honestly, I feel very proud again.
Good.
I
I'm
really
proud.
lifted my spirit.
Nice, dude. Sick. Okay.
Congrats,
All right. What's up, Swaz? What are we doing, dude? What are we doing
What's up,
today?
dude?
What are we doing? This
So-
looks like math.
Yeah, man. It is. It's a little bit of like economics question mark. I mean,
Okay.
my physics teacher gave it to me. So
Why is
I
your
don't know.
paper? Why is your paper fucking purple? This is a beautiful green.
Oh, dude. Yeah, okay. I can show you it real quick actually. Here, give me one sec.
Like, how does this look? This is like the most beautiful gradient of purple I've ever seen.
Yeah. Here, give me one sec. I'll show you. All right.
Okay, yeah, show it to me.
I have a light. It's pretty sick. Here, give me one sec. Yeah.
Let me get you in. One sec. Let me get you in there. Okay, there you are. Cool. Oh, I see. Oh, dude,
Cool
that's
mushroom.
a dope ass mushroom, dude. Oh wow, that's cool. Nice.
I know, bro.
Okay, cool, dude. That makes sense.
Yeah, no.
Okay.
I picked that up like maybe a week or two ago. It was pretty cool.
Oh, nice. I like mushrooms.
But yeah, so I'm just wondering. I'm kind of stumped on like, what formula to use
Yeah.
and name for both of the
Okay,
questions.
here, let's get you the equation for compound interest. I don't remember it off the top of my head, but compound interest formula. There we go. That's all I wanted. And then there's like a continuous one.
Yeah, well, he was doing some like whack stuff, dude.
Was he?
Yeah,
Strange.
like
man.
I don't know. It's
Okay,
like
well, This is
I guess it
compound
wasn't whack,
interest.
but
This is compound interest is what it is, okay?
all right.
So what we're gonna do is the amount, which I guess is what they call the future amount, right? The amount it costs. This is like at time t, is equal to the principal. This is the initial amount. I usually call this like A1 or A0 is really what I call. And then it's 1 plus the interest rate, okay, as a decimal over n, okay, and then n is the number of times it's compounded per year, and then t is the number of years.
Yeah.
Okay. So in this case, right? 12,000. Which variable is that? What is that thing? What's the 12,000? The deposit.
That's I have it written out here. I said 12,000 equals
No.
one
So the
plus.
future value. This is how much it's. So 12,000 is how much the deposit was initially. They want to know how much it's worth later in time. Like with T.
Oh, I read it wrong. I read it completely wrong.
Yep. Yeah.
I read it
Pubs is
as
right.
the future value is.
Oh yeah,
so,
no, the
like,
future value of 4. So
My bad. That's what I meant.
you're good.
That's
So
what
it's 12,000 here, which is the principal, and then it's 1 plus, and then you need the interest rate as a decimal, right? So how do I write this as a
Yeah.
decimal?
I meant. 0.0725.
0.0725, good. And then over n, so how many times is it compounded per year if it's compounded annually?
Just once.
Good, just
right.
once. Yeah, right, good. And then n again is just going to be once, right? And then t here is going to be what?
That should just be 10.
10. Yeah, good. Nice. See? That's all you got to do. Pretty easy. Formula.
Okay.
I assume you know how to do that. You know how to plug this in your calculator?
Yeah, no, I know how to do it, dude. It's just I
Okay.
swear my teacher was doing something some wax.
Do you have the
stuff,
answer?
bro.
Do you have the answers from what they got? I mean, we can
no,
check.
dude, I don't have the answer. I don't have the answer because this was like actual homework for the first time in forever. So,
Your teacher's actually giving you homework?
well, I don't know, bro. Like the only people who give me homework are my math teacher, but even like that homework, it's like
I mean,
not
I agree.
enforced. Like I'm taking
You should do homework. Homework's the only way to like learn.
no,
Otherwise you're just like
I
reading
entirely
shit.
agree.
Nothing happens.
Yeah, I entirely agree. But like the problem where it gets me, bro, is like
What's
I
up?
just need to be on it more
Oh yeah,
because
okay.
like if it's not enforced on me, bro, like it's not getting done.
Yeah, that's called
Like 100%.
procrastination. I get that, bro. And like, believe me, I work the same way, man. Like, if I don't have a deadline, I don't really do things. So, and this is something you'll get better at as you get older. Is you have to set deadlines for yourself.
Yeah, I get that.
Yeah. What's up, Ethan? Ethan, what's up?
Everyone.
Yeah.
I am not working like procrastination anymore.
Good.
This time I gotta try and do my work as early as I can, but if
That's
I'm
good.
very tired, I really can't work out myself any
It's
longer.
okay. I mean, I like
So
to
I have to rest
always just set like little rewards and goals, you know. So what I would do is I'd say, hey, I'm gonna go play Fortnite for an hour if I, get this report done. And then I'm like, okay, I got to do the report, and then I can go play Fortnite. Like set like little goals and stuff.
Honestly, there is really no achievements or anything I'll get out of this. The only thing I'll just get out is just watching videos at this point. So
Okay, cool.
not
Yeah,
really
good.
too much pressure for
That's okay.
games. So that at least makes me stop getting addicted to games.
Oh, there's nothing wrong with being addicted to games. Just make sure. I mean, any addiction is bad, but I don't think there's anything inherently wrong with video games. I think it just comes down to motivation to do other things. If I find myself spending 30 hours a week playing like the finals or something, it's because I'm not motivated to do other things. So instead of telling myself I'm not going to play video games, replace that with I'm going to do blank instead. If you tell your brain to not do something, it's going to focus on that thing anyways. It's like they call this the elephant in the room. If you say don't focus on the elephant in the room, you're going to be like, "Oh, what elephant?" and then you're going to focus on it. So if you tell your brain don't play video games, you're going to still think about video games. If you tell yourself go to the gym or do my homework before 6 p.m., then naturally you will do those things and you won't think about doing video games. So that's a little strat.
Okay, I get that.
PUBG says, what's the difference between bond coins and MT coins? Bond coins is the general currency for the server. That's how you can get any of the tiers for buying gift cards, video games, whatever rewards. And then MT coins are for the tournament. We have that kicked off officially yesterday. And that's for a big prize. The big prize is at the end. I'm giving out PS5 at least. Probably some other stuff. Yeah, for tournaments, yeah. Okay. This one's weird, though, here, Swaz. What is this? Annual deposit to ensure a future value?
I just tried setting that one up. Bro.
Oh, yeah. No, this is weird because you're constantly depositing. Does that make sense?
Yeah.
Oh, fuck. Okay. Bro, what?
Yeah, no, I was looking at it. I was like, what?
Well, Because what's happening here is, okay, so annual deposit. So let me go through the math of what this is. Let's call our annual deposit, let's call that just P. That's the amount we deposit every year, okay? So in the first year, right? Okay? The amount that's going to turn into is going to be P, and then it's 1.0725, right? And then this is going to be to the 10. Because it's compounded annually, so this is just 1 and this is just 1, but this is T, right?
Yeah.
Okay. So the first year, I put down some amount P, and 10 years later, it's worth this, okay? But I don't need that initial deposit to turn into 12K. I need a series of deposits to turn into 12K, okay? So this is the first year. And then this
So
is
that-
the...
is it-
Yeah. Yeah, go on. You got it.
I was gonna say, could you just do P over 10?
No, because look what happens here. Because the next deposit I put in only accumulates interest for 9 years.
Oh, I see.
Do you see? And then the next thing...
Oh wait, yeah, that's wacky.
Yeah, isn't that fucking whack?
What?
It's kind of whack. Yeah. Because then it's P 1.072. Well, let's see if there's a pattern. Okay? So I kind of see something here. Do you see? Because you see how I'm adding all these things, right? So I think we're gonna write this like as a series. There's probably a nicer equation for this, but let's see what it is. So your
Yeah,
total,
no, I think so.
your total that you make, right, is always going to be equal to P, and then it's times this 1.0725 to the 10th plus 1.0725 to the 9th, right? All the way to plus 1.0725 to the first. Okay?
Yeah.
This is actually cool. This is really fucking cool. Because this relates, Taco, this relates exactly to what I just went over with you earlier. This is a geometric series. I'll show you why it is. Okay. Do you see how I have P times... So let's flip the order, okay? Let's flip this as 1.0725 to the first plus P times 1.0725 to the second plus blah, blah, blah. Right? Plus P times 1.0725 eventually to the 10th, all right? Do you see how this looks like? Do you see how we're adding things and we keep increasing this number?
Yeah.
It's a little tricky to swap. Let me know if you don't see it. I can show it to you. Like I'm pretty sure I can figure it out.
Yeah,
How to show
no, I understand it. Yeah.
Do you see this? Yeah. Do you see? Okay. This is a series. It's a sum, is what it is. This is the sum of P times 1.0725 to the n from n equals 1 to n equals 10. Have you seen things represented in this way?
I don't think so.
Okay, here's another example. Let's say I have this. Sum of n equals 1 to 5 of n squared. This is equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Okay?
Oh, yeah, I've seen. Yeah, okay.
Okay, cool. That's a sum, right? That's what this is. This whole thing here is the same as this. You see how it's always P times 1.0725 to some power, and that power keeps going up?
Yeah.
Yeah. And it starts at 1 and it goes to 10, right? Now, there's a little technicality here. I don't know if we count, like, on year 10 when I make the deposit as that counts towards my 12K. You know, you get what I'm saying when it says, like, in 12 years? Yeah. Because I think what's happening here is I think that I think on the 12th year we still count that deposit. Maybe, let me think. Annual deposit in 10 years. No, I don't think we count it. Okay, all right. Do you get what I'm saying? That, like, so on the 9th year, right? You're gonna put some amount, and then that's gonna increase with interest for 1 year. And
yeah,
then on the
and then you just add plus.
and then you add it, right? But then on the 10th year, you would technically deposit another amount again. But I guess it's like at the end of 10 years is what they're saying. Yeah. I think they're saying at the end of 10 years. This is the whole fucking off by one issue. I hate this. This happens a lot in computer science. It's like, do you start counting at 0 or do you start counting at 1?
Yeah. No, I like this way, but there's an equation he definitely gave
No,
us.
I'll show you. I'll show you because this is a geometric series. This is a geometric series, okay? Right?
Yeah.
So, if I re-index this, okay, this is the same thing as I think I re-index this. I need to make this like n-1, and then this is gonna go from 2. Oh, yeah, this is a geometric. How do I re-index this? Fuck. Yeah, indexes do start at 0 in computer science. Yeah. What this is gonna eventually, yeah. One sec. I need the geometric series. Geometric series formula starting at 1. Just give it to me starting at 1. My brain's hurting a little bit too much to index this. Yeah, this starts at 0. Oh, but they do it to the n-1. No. Okay, I think I know how to do this. Well, that's an infinite series.
You're all good, man. We can move on to the other ones if you don't want to.
No, I like this one. I like this one. It's good. It's a good
Oh, okay.
question.
My
It's a
bad,
very
my
good
bad,
question.
my bad.
It's a good question. It's just I got to remember how it works. Okay, let me get this. It's a tricky question. I just want to see do you have the formula your teacher gives you?
I know I'm supposed to have it somewhere,
Oh, like he doesn't have
but
notes?
like I couldn't tell you where that is, man.
Okay.
Actually, wait.
Does it look something like this?
Here, wait, let me look. It might. Yeah, I think that might be what it is.
Yeah. Let me think.
I mean, I can check right here real quick. I think.
What's up, Unaccessible? Come on up.
Hey guys.
What's up, dude? Sorry, I'm getting like a little boggled by this question. One sec. Amount needed to add annually total compound.
Mr. Gold, are you trying to retire?
No.
Aw.
Dude, what is this? No, dude, what is this?
Yo,
What was the keyword they used in this thing, dude? What was the keyword they used? They said okay, annual deposit. Annual deposit to ensure future value. And then this is a compound interest. Yeah, and then yeah, where's my I just want the equation. Yeah.
No, I have zero clue what the formula is.
Yeah, this is it. Oh man. No. No, but yeah, no. But your teacher made this tricky. They made it so that like you kept adding it. Like you keep making deposits.
Yeah.
Ugh, I'm so close. I am so close. I just need to. Okay, let me just put my hat on. I just have to remember how to re-index this. That's all I have to do. Okay. Let's make this n-1, which means this is going to start at 2 and it's going to go to 11. Okay? Here's what I did. Because I need this to really start as something to the first power and then go to the 10th. But now I'm going to have n start at 2, so it's 2 minus 1. So it starts at 1 and it's going to go to 11. So 11 minus 1 is 10. This is called re-index. I know this is kind of weird. It's called re-indexing a series. So if I have, for
I'll
instance,
probably just I'll learn this later, I bet. But
no, maybe you will, but okay. For instance, but this is a good concept to know. Okay, let's say I have this of like 2 to the n, right? Do you see how this is like 2 to the first plus 2 to the second plus 2 to the third plus 2 to the fourth plus 2 to the fifth? Okay. Does this make sense here so far, Suave? This?
yeah.
Okay. I'm gonna change this to say 2 to the n minus 2. Okay. And then I need to figure out what my starting and my final index need to be. Okay. So in order to get the same result, right, to get 2 to the 1, what does n have to be for the first thing?
2 to the third.
Good. N is to be equal 3, right? Because this would be 2 to the 3 minus 1. Or 3 minus 2, right? See how that's just 1? Yeah, good pub.
Yeah.
And then what does the last one need to be then? What's the last index have to be if I want it to be 5?
7.
Good. Good. Okay. This is a valuable skill. Like beyond your class that you're taking, this teaches you how to re-index a series, which is something you will do in calculus. You will have to do this. Okay. So that's how I turned this series into this series. Okay. The same thing is what I did here. Originally, I wanted this to go from 1 to 10 of n. But for geometric series, I need this exponent here to be n minus 1. So I made this an n minus 1, which means this is now going to start at 2. Okay? In order for it to start at 1 like it regularly did. And it needs to go up to 11 in order for the last exponent to be 10. Okay?
Oh, okay.
Okay. You should show your teacher this. I want because then you'll look really smart, and then your teacher will be like, "What the fuck? How'd you come up with this?"
You
Okay.
did that?
Yeah, exactly. Okay, so here, let's get rid of this. Okay, so, okay, what I do know, right, from a geometric series, is that the sum. Oh, let me get the pen bigger. Okay. The sum from n equals 1 to 11 of p to the 1.075 n minus 1, that's this. Do you see how this is 1 to n, a sub 1, r to n minus 1? This is going to equal a1. A1 in this case is p. And then it's 1 minus r. R in this case is 1.075. So remember, this is a1. This is r. What was this? 1.075 to the 10th. Okay. No. To the n. To the n is to the 11th. Okay. Over 1 minus 1.075. Okay.
Okay.
Uh-huh. Let me make sure that's right. This is going to be negative, though. Is that okay?
I say we ball.
I think this is... Yes, no, this is okay, because this will be negative as well. Okay, cool. We're great. Okay. And then, okay. Right, so that's how much this series would be. But I need to know how much this series would be, which would be starting at 2. Okay? So if I have the sum of a series that starts at 1 as this, right? So for instance, if I have my series that starts at 1 as like 2 to the 1 plus 2 to the second plus 2 to the third plus 2 to the fourth, but I only want to know what the series is that starts from 2. See, this is like n equals 1 to 4. But let's say I want to know the series from n equals 2 to 4. You see how that's going to be missing a term?
Yeah.
Someone says I should do a speed run of the New York Math Regents exam. What is that? Like, is that like the SAT or something? Yeah, send it to me, dude. I mean, I'm down. You got a link for it? Or can you post links in here? I forget if people can post links. Join my Discord. And send me a DM. I'm Dr. Gold. Okay. Which term is this one missing compared to the one that started at 1?
That one's missing 2 to the second, right?
It's missing 2 to the first. Do you see how this do you see how the series that starts at 2 is missing the first term from the one that starts at 1?
Wait, why though?
Because this one starts at 1, right? 2 to the 1, 2 to the second, 2 to the third, 2 to the fourth, okay? This one starts at 2, so it's 2 to the second, 2 to the third, 2 to the fourth.
Oh.
You see how it's
Yeah,
missing
I got
this
you.
one? It's missing this one, right?
Yeah.
So the series from n equals 2 to 4 is equal to the series from n equals 1 to 4 minus the first term. Do you see that? This is equal to this, but without this, okay? So here, this is my full series, right, from n equals 1, but I need this without the first term, okay? So the sum from n equals 2 to 11 is going to equal whatever this is, right? The p times whatever. Let's just copy it. So I have copy paste. It's going to equal this. Oh, no. Go away. No, don't do that to me, girl. Whatever. Fuck you. One sec. It's going to equal this minus the first term from this, which is P 1.075. And then the first term, right, is 1 minus 1 to the 0. So this is all just going to be 1. Okay? Okay? This is, again, this is the first term of the sum of n equals 1 to 11 series, okay? And then this total, all of this needs to equal how much? 12,000, right?
Yeah, 12,000.
Okay. I think your teacher made a typo on this one. I think that's what happened because it shouldn't be this tough. Okay. Is equal to 12,000. Okay. All right. Now watch
Okay.
this. Okay. So this is a number and this is a
man
number.
made this problem.
What's up?
I said this man made this problem impossible.
Well, there's some.
Like-
I think there's some wording wrong here, is what there is. Okay, because watch this. All right, because now I can do my calculator. Let's get what these numbers are. So I got 1 minus 1.075 to the 11th, which is basically gonna be fucking like, yeah, dude, Jesus. All right. And then I divide this by 1 minus 1.075. Okay, and that gets me that 16.2. Okay. So I get P times 16.2 minus P has to equal 12,000. Okay? So this is going to be 15.2 P is equal to 12,000, right? Divide by 15.2, divide by 15.2. P, so watch this. So this is, what is this? This minus 1.
Nice.
12,000 divided by it. And there you get. You get $789 and 05 cents. Wow, thanks for the follow, Bakken. Yeah. That's the answer. 789.05. Yeah. I know, you're probably like, Swab's like, dude, like, fuck this, dude. Dude, fuck this.
Dude, I don't know what I'm supposed to, like.
No. Bro, your teacher made a mistake. There's a typo here. There's got to be a typo. Okay. Annual to deposit. Okay. You know what I think? I think she meant present, like initial. I think she meant initial deposit. I think that's
Dude,
what she
my
meant.
My teacher's like a brigadier general, and if you ever like say anything wrong to him, bro,
Okay.
it's like he'll start pressing you.
Here's
for,
what I
like,
want to know. I want to
no
know what the answer is to this. You ask what the answer to this. If the answer is not
Okay,
this,
I'll ask.
okay, then what they meant was initial deposit, not annual deposit. Annual deposit means that you are depositing every year. And again, that is a huge clusterfuck of math to figure that out. I had to teach you geometric, which is cool. I mean, it's cool to know this geometric series. It was a cool puzzle, but yeah, no. Oh, wait a minute. Oh, okay, no, maybe not a typo because they do it to you again here. They do it to you again right here, dude. What? Dude, okay, wait one sec. There's got to be an easier way to do this. Is there an easier way to do this without having to invoke geometric
Dude,
series?
here, wait,
dude?
wait. Do you want me to? I'm gonna ask one of my friends on Snap real quick.
Okay. One
'Cause
sec.
there's no shot.
Well, there may be an easier equation for like constantly depositing something, but
There has to be, right?
do you need to deposit in the bank? And it's okay because like, well, no, actually it's not okay. Yeah, it's really not okay. Because yeah, we came up with a general formula. Yeah, here we go. Okay, here it is. Yeah, bro, this is so wrong. Yeah.
Annual deposit to ensure.
Yeah, no, I see this. I see on Chegg, they just say it's the initial amount, which is wrong. No, here we go. Yeah. Mm-hmm. There is a formula for it.
There is.
Yeah. It's very similar to what we did though, which is cool. And it uses a geometric series is what it does. One sec, let me dump this in my chat.
Oh, okay.
I need to dump this right here. There we go.
Lighten the mood. Why'd the chicken cross the road?
Why did the chicken cross the road, dude? Why?
To get away from KFC.
What's wrong with KFC?
I know my joke sucks, but I don't know what's wrong with KFC.
No, that's okay. Okay, here you go. This is the no, that's not it. Excuse me. Copy image. Thank you. One sec. It's kind of cool where this comes from, actually. There we go. This is the equation. Okay. Where yeah, okay. So here's the equation. This is right here. This is the this is like the amount you deposit. This is the future. I is the interest. And then M is
Is that like
how many times deposited?
yeah. Okay.
Which I hope is also how often it compounds. It has to be the same. And then N is the number of years.
Okay. Yeah, I mean and then F is that's just P, right?
Well, let's just see if we get the same amount, right?
Or
Okay.
wait, what?
So for this one, the amount you deposit, that's A, what we're trying to figure out, is equal to the future amount, right? Which is 12,000. And then the interest is 0.0725, right? All over annually, right? 1 year. And then this is 1 plus 0.0725 all over 1, right? But then this is to the 10. And then it's minus 1, right? Because n is the number of years. Okay, so let's just see if we get the same answer. And
Okay,
then,
yeah, no, this This looks
Yeah, but it's just interesting that this is a kind of an obscure formula. Honestly, I haven't seen this one in a long time. So,
Oh, dude, my phone's on like one shot.
oh, dude, what? Charge your phone, dog.
Nah, dude, it's my room's got a wacky layout, so like my charger's over
Oh,
by
you
my
guys don't
bed,
have you don't
and
have
like
portable.
I'm at my computer right
You don't
now.
have portable chargers. I have batteries.
Well, I
everywhere.
mean, like I don't know. I don't feel
Oh,
like
okay.
just charging up
So they
a portable
get
battery to take everything.
858. They get 858 for this one, which I think is because they're counting. I think they're counting the last year as a deposit. I think it's the starting off by 0.
Oh, okay.
Yeah. It's
So it's 9%?
probably
Or it's 11.
well. Let's see what like math wise they got from that. Sorry. So, I had this right was equal to F. So then F was equal to. Sorry, then P is equal to F over that. Okay, so this was F times 1 minus 1.075 over 1 minus 1.075 to the 11th. It's kind of close. This is kind of close. Oh, it is. It is actually cool. Watch this. 1.075 minus 1. This is just the interest rate. Okay. And then this flips. And then it's 1.075 to the 11th minus 1. Okay, cool. Yeah, they count the last year as a deposit is what they do.
Okay, so it is to the 11th.
It is to it so I didn't need to do this. I didn't need to subtract this one. Yeah.
Oh, okay.
Yeah, I was allowed to so instead of this going from 1 to 10, it should have gone from 9 to 0. And then this would go from 0 to 9. Because what happens is your first deposit would like vest for 9 years, and then your last one vests for 0 years. Is kind of what we say. Because the last deposit you make, yeah. Or actually, no. I take that back. No, I take that back. I take that back. Sorry, this is still 10. But it goes 10 to 0. Sorry, that's the difference. That's the difference. This goes 10 to 0. Yeah. And then this would be 0 to 10. Yeah, okay. So sorry, the first deposit still vests for 10 years, but you're allowed to make on the 12th year that last deposit you make, that goes towards your 12,000. That's what they're getting at.
Okay.
Okay, I was confused whether that's true. Okay. So, at the end of the day, yeah,
I ended up getting $405
when you did this?
when I plugged in. Yeah,
For this?
I got 400.
Oh,
yeah.
we gotta work on your math skills then. Your calculator skills, yeah.
What?
This
What
right
did I
here.
do?
This right here should have gotten you what did I say? Should have gotten you sorry. Should have gotten you 858.32.
How? Wait. How'd you put
So-
it into the calculator?
so
I think I might be bugging.
So look, 12,000, right? Do you see that? 12,000.
Yeah.
Okay. And then I multiplied it by the 0.0725, all in parentheses. All of this is in parentheses, right? And then it's divided by 1.0725 to the 10th minus 1. This
Oh,
whole
I didn't
thing
have
here
the- Wait.
needs to go to the 10th, and then you have to have a subtracting from 1.
Okay, I thought I had that. I guess I didn't. Huh? Oh wait, I didn't have the -1 in the parentheses.
Oh, yeah.
I don't know if
You
that
need-
makes a difference though.
It does, yeah. Because
Oh, it does.
because
Okay. That might have
because you
been- that
need
might have
this
been where I
thing.
flubbed up.
You need this thing to divide by everything. Right? And then these are pretty easy, right? This is just 12,000 is equal to P. And then it's 1.0725 to the 10th.
No, dude, I'm doing something so wrong.
Okay,
I
do you
don't
want to
even know
do
what
you want
I'm
to take a
doing.
picture of your calculator?
Okay, so I'm using my phone as my calculator right now.
No, don't do
so
that.
might
No.
I have an app. It's called TI-84, and it
Oh,
literally
okay.
just looks like a TI.
Okay. The app's okay. This app's, yeah, don't use that fucking Apple keyboard thing or whatnot. That does not use
No,
order
I'm
of
not
operations.
using that.
Okay, thank you.
I'm not
Right.
using that.
Yeah.
You're not gonna catch me using that.
Well, okay, this is literally an 84 on the screen. You see this, right? Yeah.
Yeah.
You should be getting the same answer.
Wait, so B is not actually equal to 789. It's equal
No,
to 850.
It's 858.32. And the difference being there is I didn't count the last year on as a deposit. I didn't count the 12th year as a deposit, but they do
Oh,
apparently.
you know what? I have mine going to the 11th, not the 10th.
Yeah, you want this? Yeah, this has to go to the 11th, to the 10th. Sorry, not to the 11th.
Oh wait, so actually, yeah. Wait, why does that go to the 10th, then not the 11th?
Because it's invested for 10 years.
Oh, okay. Oh,
Yeah.
yeah. Okay.
I'm saying the
my bad.
11 thing had to do with this. I derived this equation, by the way. We derived this equation using a geometric series is what we did. But for
Yeah.
all intents and purposes in your class, you really only need this equation. You can just plug and chug this. I just thought it was cool to see how that'll work.
For sure, dude.
Mungie says, "Do you think Danny would be interested in the AMA stream?" Yeah, sure. I could ask Danny. Is Danny here? Do I have him as this? Is Danny Highway work? Or what is it? It's Oh, I don't have Danny Highway added. Oh, I should add him. Oh, that's dumb. No, he is there. No, there he is. Yeah, Danny Highway's at the top.
This seems really peaceful.
Yeah, we're just chilling, dude. Okay. Did you get that right? Did you get that right, Swaz?
Yeah. No, I put it back in. I just had it going to the 11th.
Okay, and then
Well-
real quick, to do this one, right? Present deposit necessary. So this means a one-time deposit. You just deposit once, and 10 years later, I need to see 12K, right? That's the standard equation you use.
Okay.
So it's just, multiply this out and then divide it over.
Yeah.
So what's that? That's
So-
12,000. Yeah, tell me what you got. Let's see if your calculator skills are on point.
Doing shots, bro. Sorry, I'm just writing it out on paper first.
That's okay.
Let's see them calculator skills. Woo.
Yeah, see them calculator skills.
Mr.
We were-
Gold, I have a test tomorrow. Are you excited for me to?
What's your test in, dude? Good luck, dude. Good luck with your test. What's your test in, dog?
We're learning about shading and dotted lines.
Okay,
I'm gonna start crying.
that's pretty
But
cool.
I just learned.
What
when
are
I
you
taught
shading, dude?
someone.
Just shade what, like inequalities and stuff, dog?
Yeah, inequalities and like inequalities.
I think we were joking about calculator skills earlier. Where was it? Okay. I show this picture all the time, but there's some students here that are new. This is a photo of me in the 9th grade taking my calculator as my date to like a high school dance.
I mean, everyone loves the calculator until they cheat on them.
Right? Or until you don't know how to turn it on. Like you gotta hit the right buttons. Yeah, but dude, this is me. This is mini Dr. Gold, dude. Yeah, look
I
at me.
hate not knowing how to turn my calculator.
There's me,
on.
but there was my TI-84. It was my date. Love it.
Mm. Still as many girls that I'll get.
I was not very into girls at that point in life. No, I don't think they were into me either.
It's a lose. It's a lose.
Win-win, depending how you're looking at it. I don't know.
Win-win. You don't have to put up with girls. Lose.
And girls didn't have to put up with me, honestly. Yeah, if I was a girl, I would not have put up with my high school self either. Yeah.
You couldn't have
Okay.
been that bad.
Yeah. What'd you get, Swaz? What'd you get for this one?
I know I have to be doing something wrong. Like,
Did you not just solve this?
no, I did. I got the Oh wait, you know what I didn't do? My bad.
What didn't you do?
That's dope.
Yo, not doing that is
Uh,
dope. That's crazy.
Yeah, it's
and then
okay. This is why
I
it's
just
good
need
to have
to-
calculator skills.
Hmm.
Oh shoot.
What good
I'll
time is
do
it?
that.
Luckily, my bedtime is
No.
pretty high.
Are you sure? Let's go. I want to ask you something.
We'll do your question, Ethan. Don't worry.
Okay. Yeah.
I
No.
hope you don't
I'm
fry your
bugging.
brains
I
out.
don't even know.
What's wrong? What's wrong, Swaz? Swaz, what's wrong?
I'm bugging, dude. I don't know why, but I
right,
did not get that.
All right, let's do this slowly. Okay. What is 1.0725 to the 10th?
Oh wait, no, I did. I got that.
Okay, you got 595,
Yeah, I did.
5959.48.
I did.
Okay, thank God.
Yeah.
Okay,
Ooh, that's dope.
okay, that's dope.
That's dope.
Hey,
Okay,
yeah.
so for this one, Swaz, okay, which is depositing it each month, right?
You just do 12, right?
Well, no, this changes. So the future amount, this is now 10,000 is the future amount. The interest is now 0.0575 over 12, because now it's 12 times per month, 12 times per year.
Yeah, that's what I was.
And then this is 1 plus 0.0575 over 12. And then this is to the 8 times 12. 8 times 12. And then it's minus 1. This is going to be a trickier number to calculate for sure.
Oh, that looks so easy. Oh my gosh.
We got it.
All right, let's see. He's on his redemption arc, dude, for the calculator today.
Yeah, really?
Redemption arc, dude.
0, 5, 7.
How do you just delete one number? Like I've been trying to delete one number for the past like 7 weeks, and I haven't been able to do that. I have
What, to
restart my
delete
whole
like on a
calculator.
calculator, dude?
Yeah, just like delete one number. Oh my.
You just
I'm
use
oh,
you just use the insert and like button, dude. What?
yeah, come on. Whoopsie.
Dog what?
You just use an insert button?
Yeah, I use the insert button. Insert button's king. And then this
Okay.
is
Delete insert button.
this one you probably might want to do in stages, honestly.
Nah. Not
You're
right
gonna get this all in one line, dude.
Yeah, man.
All right, let's do it. I want to see it, dude.
Not one bump, man. One line.
One line, he says, dude.
Uh,
It's a hard one. This is a tricky one, dude. I'm like I'm having to keep track of like my third one at this point. Fuck. Yeah, no, see,
Alright,
see,
please
I'm off
be
by,
right, bro. Like, I'm not trying to.
I'm off by one. I'm off by one actually. There we go. Okay.
No, that's not right.
What'd you get?
No, I did not get that. I think I had an extra like bracket or something. Not bracket, but parentheses somewhere. I got negative 999. Yeah, dude, I am.
There you go.
Or not
82,
negative 900, but I
80
got negative 9,000.
82.28. 82.28 should be the answer.
Okay, I did not get 82.28. So
Okay. All right. Well, this is a
I
calculator thing.
somehow got that.
Calculate this number individually on your calculator. Calculate this number individually on your calculator. Do this minus this. Do this divided by this. Multiply by 10,000. Don't try to do it all in
Yeah,
one
no,
line.
I mean it's just a skill issue, but
It's a skill issue. Yeah, as long as you get it conceptually. Nick
Yeah,
said,
alright.
"Did
Yeah,
you
that
know
was it.
sex
I
is
really
good,
appreciate
Nick?
that.
What? God damn it, Nick."
Yes, it does. Did you do it?
Okay, cool. Yes, congratulations. Yeah. Here, place out, inaccessible. Yeah, waiting for it. He's gonna place out, dude.
Thank you so much, Dr. Gold.
You're very
I really
welcome, dude.
appreciate the help.
Yeah, you're good, dude.
Alright, thank you.
Yeah.
I'm scared my parents are on a call.
Okay. All right.
Gotta go.
Let's get to our last question of the day.
Well, Ethan, I'm not gonna be here for your last question, so peace. Bye.
Say, I don't even care if he's in question or not. I don't care, honestly.
Okay. Last one. Already, he says? Yeah, we've been almost streaming for
yeah.
2 hours.
Actually doing a level as well.
What's up, dude? What's this? Oh, fuck. Okay. What are we asking for here, Ethan? What's the question? Is the question to find the
Alright,
shady
sorry.
region?
Yeah. Wait. Hold on. Let me find it. Sorry about that.
It's okay, dude. Oh, and we don't know. Oh, we don't know the angle. Right?
Hold
we don't.
on.
We don't know the
hold on.
angle.
So we're trying to find the area of a segment.
Okay, but I need an angle here.
Wait, that the angle is C right there. We don't know
Okay.
the angle.
Okay, that's all right. That's all right. I get it. I get what we're gonna do. It's okay.
Yeah,
Okay.
apparently the teacher used cosine rule. I just want you to explain it to me so that I can actually get it instead of just memorizing what I need to do.
I agree.
It's just like what you said for formula.
Yeah, fuck formulas, dude. It's better to like learn things. Okay.
Hey, come on. I use formulas in my life.
I know, I do too, man. But it's okay. Okay, I'm gonna use magenta for this one.
That's Genta.
Magenta's like kind of a pink, like a pink.
Oh, okay. I wonder how many colors they name. Like, there's
No, there's a
obviously
lot,
the
dude.
basic ones, but then there's like literal different ones, like
Bro,
magenta.
Yeah, there's a gazillion colors, dude.
Just
Actually, I think there's technically 256 million colors.
okay,
Nope.
that's too much. I thought there was
Has
just
to do with
12.
bit, has to do with bit depth, is what it is. I think it's 256 to the third is what it is, because you get 0 to 255 on RGB. It's actually kind of a cool thing. Have you ever seen like colors represented as RGB? Let me show you guys.
No.
Kinda cool. Okay. Here, like, where's? Let me just like 1 second. There we go. Cool. All right. Do you see here how you can pick like a bunch of different colors, right?
Oh, yeah, it's true.
Do you see all these colors? Right here.
Yeah,
Like,
I see them.
Okay. Every color in what's called 256-bit colors can be represented by 3 numbers. Do you see down here? There's an RGB number. See
Yeah.
RGB.
What's
Okay.
that? What's that for?
So, if you mix certain amounts of red, certain amounts of green, and certain amounts of blue, it makes a unique color. All right? And the amount you mix can be anything from 0 to 255. Okay? I think this is called
Okay.
16-bit. 16-bit color is what it's called. Yes. Yeah, that's wild, right? Yeah. So all the colors, like any color, like like I know you like blue, Ethan, right? But like, look, even within blue, right? I can have a really light blue or kind of dark blue or this or like a ultramarine blue. These are all represented by different RGBs, and it's actually cool. This is how monitors work. So RGB up close. So your monitor has on the individual pixels here. Has red lights, green lights, and blue lights. And then the strength of the brightness of each of them is what helps your eyes perceive different colors. It's literally this. It's literally these are called pixels. A pixel has like a red, a green, and a blue part to it. Yes, you're right, Monkey. Yeah, if you blast all of them at the same level, you get white. That's the only. Well, I mean, it's the 3 colors that we came up with. RGB. It's cool. It's just it's what do we call this? Like a color wheel.
Red, green, and blue stands for RGB, right?
Yeah, it's RGB. It's you can mix different amounts of red, green, and blue to like create basically every color that we perceive. Yeah, it's very cool. I like OLED screens because they save your battery and they look good too. Yeah, and OLEDs are interesting because OLEDs don't use power, I think, to display black, which is why the blacks are very deep with OLED. There's probably a whole thing into that. But yeah, so if you want to know the total combinations of colors, right, it's 256 to the third. Because you have 256 options for red, 256 options for green, and 256 options for blue. So if you multiply all of these three numbers together, okay, here's the total number of colors in 16-bit color. So I do, what is this? 256 to the third, you get this answer. So what's that? 16,777,216. Those are the total number of colors out there, I guess. Yeah. It's a lot. As far as like names for colors, we obviously don't have 16 million names for all the colors, but we have specific names for certain colors, which if you really want to get into that, that's for instance what like Pantone is. Do you guys know what Pantone is?
No.
Okay. So Pantone, what they do is they put a name to each one of these colors, and they've come up with like a system. So for instance, can I just see this, please? Fuck. Like, okay, there we go. Like they call this like something C, something this, but then there's like names for them. There you go. Like black, Amparo blue, reed yellow, poppy red, dark cheddar, jolly green, antique moss. Yeah. Primrose yellow, island paradise, right? This is a company that has put names to all the different colors. It's called Pantone. If you get into the design world, yeah, this is like look at it. This is pretty cool. Whatever, just can I see
Honestly,
this?
I do agree.
Yeah, like can I just see this? Is this really behind a paywall? You motherfuckers. Whatever.
Really?
Yeah, it's dumb. But yeah, cool. Colors. Yes. All right. It's funny because I one of my friends, his dad created Pantone, and so he's worth like billions of dollars because he created like the company that comes up with colors. Yeah, it's nuts. Yeah. Doggold, you say a bad word? Yeah. Yeah, design industry is all sorts of cool. Okay, back to this question though. All right. So if I know this is 13.1, Ethan, okay, and I'm trying to figure out this area.
You know the shaded region.
Right. I don't know the shaded region. I need to figure out the shaded region.
No. That the goal 13.1 is the shaded region, I think.
No. AB is the length from here to here.
Oh, okay.
Mm-hmm. If I want to figure out the shaded region, I need to know what this angle is, okay? The way to get this angle is to recognize...
We can call it angle C.
Sure, call it C. I don't care what you call it.
All right.
We call that C. This angle can be formed from like a triangle. Yeah, this is like 90. Okay.
Yeah.
If this whole thing is 13.1, how much is this?
Wait, don't you have to, how do you say it? You just gotta have 13.1,
Yes,
which is
yeah.
a divide.
Yeah, it's good. So this amount is going to be equal to 6.55.
It's 6.55. You're not showing a calculator.
No, I just did it in my head.
Okay.
Okay. All right. So if I want to figure out angle C, then how do I do that?
Okay, Dr. Gold, this is not how I did it.
It's okay. Well, I'm going to show you the way I do it, so it's okay.
Dr. Gold, I don't like new methods. I'd rather take them for different stuff. It's like
Well,
new methods are fine, but they're illegal. That's what a teacher
This is
would
not
say.
illegal, dude. Fuck that, dude. It's not illegal. This is okay. This is totally
Are you
legit.
kidding me?
This is math. Math is math. There's nothing illegal about what we're doing here. We're not cheating.
No, but we're changing up what I would actually do.
Okay.
I would just use the cosine rule, and then I would just figure it all out.
Oh, okay. Oh, you want to use law of cosines? Oh, sure. Okay, yeah, that's fine. We can still do that too. Yeah, all right,
See,
whatever.
that-
Whatever. Yeah, you're
This is
cool.
good.
I was gonna create a right triangle and then do tangent, or sorry, I was gonna do sine. Right, sine is opposite of hypotenuse, and then I was gonna figure out what the angle
Yeah.
was and times by 2. But you also don't have to do that. Cool. Yeah, we can do the other one as well. Yeah, let's do that. Let's do law of
Cosine
cosines.
rule, please.
That's fine. Yeah, that's okay. Whatever. Still works. Okay. What am I gonna do with the cosine rule?
So see, here's how my teacher wrote it. It goes as the following. It's like, it's gonna be, how do you say it? C, could you write C squared is equal to A squared plus B squared minus 2AB minus 2AB and the cosine times the cosine of C.
Yes.
Well,
Or theta, whatever. Yeah, call it C. It's okay.
so yeah, and then this is what she would do. She would
Mhm.
actually cancel the squares out.
No. You can't cancel the
by
squares
square
out yet.
rooting. No, you can square root, and then she
No.
would just cancel them out, and then you will be able to solve it.
No.
Are you sure?
Nope, can't do it yet. Nope. Because the problem is, like, I could square root this, but square rooting this is a mess. You don't want to do that.
What? You just canceled the squares.
Yeah, but what about this thing? This thing don't have a square on it, dog.
Well, truth
Square
be
root-
told,
Square root of a squared plus b squared does not equal a plus b. Don't do that. Don't do that. That is not right. It's a common mistake kids make.
Or no, wait. I think I said it wrong. It's like what she would do is that she would square root, but she would square everything, right?
Yeah,
That's how she did it.
Well, I think that's wrong. Why not,
only I could
doctor?
visualize it would mean you would get it, I guess.
You want to square root this and then square root the whole thing?
Yeah, she would do that, and then she would put the square, the square, the little exponent 2 on top, and then that would cancel everything. Then that wouldn't be a mess.
Well, this would cancel, but it's not going to cancel this. No, it's not going to. The square root will cancel a single square underneath. It'll also cancel squares if they're being multiplied. If they are being added, does not work.
Okay.
Does not
Tactical,
work.
This is really hurting my
Oh, but
brain
for
now. I
real,
thought I
why
could
would it
have
not cancel? Okay, well here's the reason. You guys want to see an example? Okay, let's say I had the square root of 2 squared plus 3 squared, right? Okay. Which is the same thing, right, as 4 plus 9, which is 13. Let's do this trick of like, oh, well that's just this plus this. You see how 5 does not equal 13?
No.
This is really hurting my brain now.
You just can't do this. You cannot square root things when they're being added to each other. You can't.
Okay then.
You can only square root things when they're being multiplied. And even then, then they multiplied. But it's still a little bit much, yeah.
All right then.
Okay.
All right.
Okay, so what are we going to do, though?
Where was that formula you had?
One sec.
The,
It was here. Form was right here.
Okay. All right. Well, I think I kind of messed that up a bit. Or my
It's okay.
teacher, I don't know.
That's right. Your teacher's okay. So it's 13.1 squared. That's c squared. Is equal to 10.
Okay, I see.
10.5 squared
Wait,
plus 10.5 squared minus 2 times 10.5 times 10.5 times the cosine of c.
All right,
Now?
that's go.
What's
I
up?
did get that mixed up. Yes, I got that mixed up. Hold on. So here's what my teacher actually did as well. So let's go.
Yeah.
Yeah. So what she did is that she saw that minus 2ab cosine of c is negative. So she actually switched it over to the other side. And then what she had was 2ab and times the cosine of c,
Yeah.
which is to a squared plus b squared minus
Minus
c
c
squared.
squared. Yeah, that's fine. Whatever. That's just algebra.
Well, then I like this better.
Well, whatever. Just do it this way.
Okay.
171.61. It's all gonna come out the same, dude. It's all gonna come out the same.
Just in a different way, right?
Yes. 10.5 squared. So that's 110.25.
That's cool. What kind of a calculator is that?
So it's a gold TI-84.
Where do you get those? Where do you get those? I haven't
Oh.
gotten that.
Oh, I created this one.
Okay, then how did you create one that does literal graph sort of functions of X
Oh,
or
it's
whatever?
an
FX.
it's an emulator. It's an emulator is what it is. It's an emulator.
Okay. I wonder so like the calculator I have right now, it does do f of x, but I wonder how far math can go because it can be into really complicated stuff that not even you can figure it out in your head by yourself.
Yeah, yeah. So you have like the TI-89 can do symbolic manipulation, which is really cool. Which means it can like move variables the same way that Wolfram Alpha does. But yeah, the 84 is really just for graphing and stuff. Okay. All right, Ethan. So here's what I did. I squared these. Squared this. I got this, right? I moved this over. I moved this over. I got this. Then I'm going to divide both sides by this.
I'm negative 220.5, right?
Yes.
Hold on, I got the answer. Hold on.
Okay. What'd you get? Ooh, my ears.
I get that same thing.
Good.
0.2217233356.
Good. It's equal to the cosine of C, right? Last step. How do I figure out C?
Hold on. Wait, I think I realized something. Don't you use inverse cosine?
Mm-hmm. Yeah, take inverse cosine on both sides.
So what you would do is that hold on. So I wasn't finished explaining.
Okay, what's up?
So the teacher actually wrote it like this: C is equal to whatever the number you get is, and the inverse of cosine C, which I think is still the same.
Uh-huh. Yeah, this cancels out,
So
Ethan.
by doing that, yeah. So by doing that, um, I hope I got the same thing.
Yeah, let's see. See what you get.
Oh. Hold on. Yeah, I get the same thing. I get the same thing.
Nice. Good job.
Wait, that wasn't it.
I know, but you know how to do the you know how to do the area of the sector. I know you know how to do the area of the sector. Once you have the angle, it's done.
Segment.
Yeah, the segment. I know. No, well, yeah, the subsector, I guess. Yeah. Yeah. Good job, Ethan.
Subsector.
Yeah, the shaded region. I know
Okay.
you know how to do it.
All right then.
Nice.
Well, I really do hope I'm ready for this math quiz tomorrow.
You're gonna get it. You're gonna do it, dude. I know you will.
All right. Well, that was a little helpful, even though you kind of messed me up a bit.
Did I mess you up? No, I showed you the right way to do it.
Yeah. You didn't do it the way I thought you were gonna do it. You did it completely different, which messes me up. It's
Ugh.
like seriously, I really need to get this out of my head. It's like, how do you say it? It's like I will literally follow every single step all the time, and I won't even change what I'll do.
Yeah, but that's being a lemming.
It's
Like, you don't want to blindly follow orders. That's like what the Nazis did in the Holocaust. Like, don't do that shit. Like,
Nazis and Holocaust.
you should do things that you know how to do, right? So your teacher giving you like the procedural of like, hey, this is what you do. That's cool. But I really want you to understand conceptually like why we're doing what we're doing. And so if I show you a slightly different method, you should understand that we're still doing the same thing. We're just doing it in a slightly different way. But the mathematical concept is the same. So that's what I want. I want you to be, more, cognizant of, like to see a little bit more. Yeah, you should do them the way that you understand the best. Yeah, I agree, PUBG. Like, the way I teach you, or the way that your teacher teaches you, may not be the best. It may not be the best way that you learn. It's okay. So just do it whatever way you learn. I think the way your teacher does it is not the best, but that's my preference.
Hey, come on. That's your opinion. You don't know
Exactly.
my opinion.
But like we were saying, like, look, this was a cool example because yes, you could have used, and we did use, the law of cosines to solve for the angle. You could have also broken this into a triangle and just used inverse sine. You could have used inverse sine to figure out the same answer as well.
All right.
Right? Because this would have been 13.1 over 2. So the inverse sine of the opposite, which is 13.1 over 2, over the hypotenuse, 10.5. Watch, this will get you the same answer. Inverse sine of 6.55 divided by 10.5 is that, and then you multiply it by 2 because that's only half the angle. Do you see how you get the same 77.19 degrees?
Yeah.
Yeah, because this was like C over 2. Same way.
Alright, then.
It's the same concept.
Let's go. Wish me luck for this quiz tomorrow.
Good luck, dude.
I'm about to take.
Let me know how you're doing it.
I'm gonna be
Oh,
taking
no.
it. Let's go. In my time, I'll be taking it at 10 o'clock, which I think for you is gonna be 8 o'clock, right? Since you're still in daylight savings, right?
Yeah, we're still daylight savings.
So
Whatever that means.
Yeah, you are really gonna have to hope for the best for me.
I will. You're gonna do great, Ethan. I believe in you, dude. I believe in you. Okay, cool. All right. With that, let's wrap up the stream. Thank you everyone for coming to office hours today. A lot of cool questions. A little bit shorter stream than last time. Not 3.5 hours. We did 2.25.
Thank goodness.
2.25 hours. But cool. I hope you guys were able to figure out, learn some stuff. You know, all sorts of things we go through. You see, it all connects, right? Like we did geometric series with Monkey, and then we end up doing the same thing to learn compound interest, and then I think there was something with like chemistry. Like there was, yeah, everything builds on itself. So, yeah. Next stream is going to be an hour later, so that will start Wednesday at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. So if you haven't gotten your weekly credit for asking a question, tomorrow's the last day to do it for this week. Make sure to try to ask your question first. And then after that, I gotta confirm who our special guest will be for Friday for the podcast. I have a couple people in the running. Maybe I'll talk to Danny. Yeah, it's just, you know, getting people to commit to anything is like difficult these days. What's up, dude?
I promise I'll not to stream tomorrow at 20 minutes before, if that's okay. If not, I can still do 10 minutes. I feel like doing
That's
10
okay.
minutes more than 20.
Wow, we have so many people on. We got paleontology and Costco. Here, do you guys want to go to the paleontology person? Let's go over there. They probably got some cool stuff. Yeah, right? So yeah. So if you still want to get credit for you know, the channel points, that's how you use to buy MT coins. Stick in the channel here. We're gonna go raid another science streamer who does paleontology stuff. Maybe go say hi to them. And so if they ask you, say Dr. Gold sent you, or Actual Education. So, all right, we'll start that raid. Thanks again to all our amazing subscribers, our Discord boosters. Appreciate all you guys. You keep the stream running, which is great, and keep me out of needing to have a job. Hope you have a wonderful rest of your Tuesday. We will see you tomorrow. Peace.
I'm about to.
I want to print those.
The modern whale's journey